Thank you. Good morning, all. If I could, please raise a hand, folks in the audience who've ridden an Amtrak train. That's almost everyone in this room. That's great to see. Keep the hands up. Anyone who's ridden the Acela? Wow, that's great. Thanks for sharing. And thanks for attending this morning's session. My name is David Cole. I'm an account executive supporting our business relationship with Amtrak. This morning's session is titled, Amtrak's Cloud Automation Exceeds Business Class. I'll be joined on stage with two Amtrak presenters. The first is Bob Hutchison, who's the head of Enterprise Technology Operations, and Shrikant Ikhtari, who's the Senior Director of Cloud Operations. Yeah, thanks for attending this morning's session. I don't know, anyone in the audience, did you enjoy any of the coffee here that's served at the convention center? But there's a great coffee holder that has the Amtrak logo on it. And I didn't realize this myself, but did you know that Amtrak trains consume less energy than auto or airline travel? How about that? That's great. Keeping the planet green. So earlier this month, in order to escape the continuous, never-ending stream of back-to-back virtual business calls, the AWS account team decided to take a field trip and hop on the Acela line to and from the new Monahan Train Hall Station up in New York City. We picked a date. We booked our tickets using the Amtrak mobile app, which I might say was very convenient and simple to use. Some of us boarded the train, an Acela train, at Union Station in DC, and some others boarded at the BWI Airport Station. But using the Amtrak's reservation system, we were able to pick our seats next to one another with tables in between, and essentially creating a mobile office environment. Except we had a continuous change of scenery running by the windows outside. And I'll have to say that's exactly what the doctor ordered to cure our cabin fever effect from the pandemic. And Amtrak offers all of its passengers free Wi-Fi service. And unlike the airlines, Amtrak's Wi-Fi service allows users to use streaming applications such as video conferencing. This way, during our trip, our 2.5-hour journey up and back, we're able to be productive and conduct business calls, check emails, and all the typical things we do in our business day. When we arrived in New York City, we took a short trip up a flight of stairs from the platform, and we're welcomed by this grand and spacious skylit atrium inside the new Monahan Hall Station. It was a beautiful sight. They even have a gorgeous metropolitan lounge that provides the highest quality service and experience to your frequent and select travelers. It was a really awesome experience, and I would urge everyone in this room and their colleagues to consider a business day outing like this one. So this morning's session agenda. Bob is first going to talk a bit about Amtrak's business background and their vision for modernization. He's going to talk about their bimodal IT, their cloud adoption journey, and even share an overview of their cloud ecosystem. And then Shrikant is going to talk about Amtrak's Cloud 2.0 initiatives. And he's going to dive a bit deeper into several use cases, including their cross-region resiliency, automation and containers development, and governance at scale architecture. Thanks for joining this morning's session, and I am pleased to introduce the next presenter on stage, Bob Hutchison.
All right, thank you, David. I appreciate the kind words and the enthusiastic introduction. Before I kind of get started with my prepared remarks, I just wanted to take a brief minute and acknowledge the really unfortunate events that took place this past Saturday afternoon when the Empire Builder train, which is one of our nationwide long-distance service trains, derailed in very rural Montana. It was a tragic event. Unfortunately, some passengers lost their lives. There were multiple injuries. And, as an employee of Amtrak, I just want to recognize and acknowledge that, our hearts and thoughts and prayers go out to the people that were impacted by that event. And, we are working with, everybody to make sure we understand what happened and what led to that. And they're all in our collective thoughts and prayers. So with that, I would like to talk a little bit about Amtrak itself, our background, kind of what the company is. There are a lot of misconceptions about Amtrak and its structure. And actually, as I was thinking about it, obviously everybody here in the room is very familiar with some of the common services. In fact, I think the only person who didn't have their hand raised, or at least I didn't see it, when Dave asked if you had traveled Amtrak, was one of my own staff. So, we got to get you out on the train and visiting New York and all these other spots. But so a little bit about background, Amtrak. Many people think Amtrak is, part of the federal government. Amtrak is not a federal government agency, nor are we your typical inner-city transit agency as well. Amtrak is a privately held commercial corporation. It just so happens that the 51% or so of Amtrak's corporate holdings are actually by the federal government. The remaining part of Amtrak is technically still held by the original legacy railroads that gave up their passenger service when Amtrak was created. So, Amtrak goes back to the Rail Passenger Service Act in 1970, and that was established at the time because freight railroad companies and host railroad companies weren't able to operate passenger services in a profitable, scalable way. And I think, frankly, they didn't think it was a long-term business model. In fact, I think many people at the time thought, passenger rail would be, with air travel ramping up very quickly, that passenger rail would be dead and gone in like 5 years. Well, here we are 50 years later, and Amtrak is, as a business model, is as strong as it has ever been. So, our job is our mission is really intercity passenger rail, create those transit trips for our customers between city pairs. We're a fairly complex business, and we operate in 3 different service lines. We have our traditional Northeast Corridor service. Amtrak owns all of the rail assets between Washington, D.C. and Boston, and we're accountable for managing, maintaining, upgrading the care and feeding of those rail assets. We also own the tracks and the services between Philadelphia and Harrisburg, and a couple of other service lines that are in New York and various other areas. If you look at Amtrak, that's a national asset for all intents and purposes. The Northeast Corridor is a mission-critical piece of transportation infrastructure, and Amtrak are really the stewards of that on behalf of all of us in the U.S. public. So we own those assets, we operate those assets. We are also responsible for operating then the passenger rail service that transits those assets. And in our most recent pre-pandemic fiscal year, Amtrak was able to operate the passenger rail services nationwide and in the Northeast Corridor at a profitable level. And that's really what we're trying to do in terms of the government's mission. Operate passenger rail service profitably while also maintaining the assets that the whole nation benefits from. So when we started service May 1st, 1971. Again, that was just over 50 years ago. We celebrated our 50th anniversary this year in 2021. We began service in 53 states and 21 routes. Those operations have matured significantly over time. One of the most significant milestones was the introduction of the high-speed rail Acela service in 2000. The current Acela is actually, we're in the process of rolling out a new Acela train. It's actually called literally New Acela right now. It's anticipated to go into service in the fall of 2022. And at this time, the Acela train is the fastest passenger rail service in the Western Hemisphere, and it will continue to be when the new Acela trains are rolled out. And I think those are going to be operating or approved to operate at up to 165 miles per hour. And so when the infrastructure is clear and we can run those trains without interruption, that's an under 3-hour travel time from Washington, D.C. into New York, which if any of you have driven that or flown that, it is by far the easiest way to get from D.C. to New York City. While you, for all intents and purposes, think of it as a rolling office. While you're working, you can walk down the corridor and get a cup of coffee. So it's a very productive, very useful service for us. At this time, we do operate in 46 of the contiguous continental U.S. states, and have over 30 routes and 500 train departures daily on a full schedule basis. Again, in pre-COVID, and in fiscal year 2019, this is really the last year that we had full operations. We had our strongest year ever with a record 32 million passengers across the company, and again, operating for the first time ever in its history, operating the passenger rail service at a profitable level. So let's talk about what is Amtrak's vision for its service. So this is kind of a little bit of an eye chart map, but what it shows is where we operate our services nationwide. So we've all talked about the Northeast Corridor. All of us in DC know that quite well. We also have the traditional national network, and the nationwide network are those classic train lines that you've heard about in the media. So for example, the California Zephyr, which travels from Chicago to San Francisco, the Southwest Chief, which goes from Chicago through the Southwest into LA, the city of New Orleans, Chicago to New Orleans. All those classic routes are part of that nationwide network. That's an important part of our heritage. It is not the most profitable set of services, but it is very important to the nation and building the economies in those much more rural areas that we tend to serve through the nationwide network. Again, I talked about the Northeast Corridor. That is a very profitable section of rail for us to run. We don't only run our own trains on the Northeast Corridor, but it is a critical national infrastructure asset. We run 5 major regional transit agencies and commuter rail services run, including the Virginia Rail Express, the MARC trains, which run in this particular area, all the way up to SEPTA in Philadelphia, New Jersey Transit in New Jersey and New York, and the MBTA system in Boston. So on the Northeast Corridor, we're tens of thousands of passengers travel and rely on those corridors, and Amtrak is the piece that keeps that critical nation infrastructure together. So where are we going in the future? Well, the future of the rail travel, we believe, is intercity transit, and looking for intercity pairs that aren't connected by rail today, where we can establish a new rail service on existing infrastructure and build a passenger-facing service. So some really good examples of that where we've had a lot of success in intercity pairs would be what we call the Hiawatha service line. If you're not from Illinois, you may not have heard of that before, but that is a dedicated rail service that runs between Union Station in Chicago and Milwaukee, Wisconsin. It has 10 or more departures per day at full service. It is our it's in our top 5 most traveled routes, and it runs on its own dedicated rail link between those areas. That's an example of a private-public partnership that we engaged with the Illinois Department of Transportation and the Wisconsin Department of Transportation to build, operate, and sustain that particular service, and it's very popular. It's a perfect example of the types of areas that can really benefit from rail, where you've got 2 cities that are reasonably close, probably less than 300 miles a distance, where there is strong population growth, economic activity, and the need to create better transit options between those two cities. Some examples where we're really looking at it, where we think there's really opportunities to grow rail, would be Charlotte, North Carolina to Atlanta. There are tracks. We do operate service between those, but it's once-a-day service. So over the next 15 years, our intention is to partner with those state agencies and build up those services so that they are multi-departure, reliable services between those two city transit points. And I'll speak one more about a very specific example here in the state of Virginia and locally where we're doing exactly that. The Virginia Department of Transportation, within the last 6 months, recently announced a significant investment in rail services in partnership with Amtrak. They are going to build a new bridge across the Potomac River, which is one of the current bottlenecks for passenger rail leaving Washington Union Station heading south. That new bridge will be dedicated to passenger rail that will be used by Amtrak and Virginia Rail Express. They are going to buy, and the state of Virginia is going to buy and rehabilitate new tracks from CSX, the freight rail operator, so that they can rehab that, increase the capacity, and get much more predictable travel times between DC and Richmond. And the eventual goal here is to increase the daily departures between Washington, DC and Richmond to up to a dozen per day. So imagine if you do business in Richmond and you live here in the Northern Virginia area, you now have a much better, much more reliable, easy to use transit opportunity than sitting in the I-95 parking lot driving south. And if you ask, I sat in one of the early presentations from the state of Virginia. If you ask them why they're making this investment, they say, well, the cost of adding one lane to I-95 is $15 billion. We can make this investment right here and significantly increase the benefit to the U.S. The benefit to our state, and not just add more cars on the road. So those are the types of opportunities and vision that Amtrak is looking for going forward. It's going to be a lot of state-supported activities, and this particular map just gives you some examples where we're looking to grow those particular corridors. If you'd like to learn more about that particular multi-year vision, go to amtrakconnectsus.com. The whole vision is articulated there, and it's really inspiring if you're a rail fan or if you're a public transportation fan. As Dave mentioned earlier, rail is a very environmentally favorable and transit option. Better than driving, better than buses, and better than air, and there's a great market for us to go after in there. Talking quickly about our 15-year vision, I covered most of those points, but just in a nutshell, we want to add services to 160 new communities, both large and small, while remaining all of the operations in our existing our existing network, and increasing the service locations to over 525 locations across the globe. Focusing on intercity passenger rail services, and we want to serve the 50 largest metropolitan areas across the nation. We're going to expand service to 47 of the 48 contiguous states, focusing on those corridors, and add 39 new routes, and in continuing to enhance 25 existing routes. The 39 new routes is a significant increase in core services because it takes all of those infrastructure services that are required to serve passengers in those particular areas. And then, our goal from a ridership perspective is to either enhance or improve ridership to grow 20 million more riders annually. We had a really good ridership base in FY19 before the pandemic hit, 32 million riders. At this point, at the end of August, which is our last full month of operations, we were operating at a little over 70% of the pre-pandemic ridership volume. That's a really good sign for us. The ridership is coming back, the demand will come back, and we're pretty confident around that. In addition, we've been able to grow new riders. A significant portion of the ridership that we are getting weren't the people that were riding Amtrak and the rails before, so we're very optimistic around that being a growing segment of customers that will embrace intercity rail travel. So let me shift gears quickly and talk about IT. So I'm here because I am an IT guy, and I have responsibility for all of our enterprise technology operations, which includes, among other things, all of our cloud services and infrastructure services, as well as the onboard Wi-Fi services that Dave was talking about. So I have the fun job of making that, make sure that's running smoothly and economically for the company. So let me talk about our journey of bimodal IT from 2012 to 2021. Amtrak has been working on our cloud adoption for almost 8 or 9 years now. And it started early in 2012 with some cloud evangelism and some cloud pilots focusing on the AWS services. That went very quickly from proof of concept trial systems into hosting production environments for the agility benefits and the cost benefits. We started with our SAP infrastructure, and early on we moved all non-production components of our SAP infrastructure out of the on-premise data center, and we're hosting those in the AWS cloud. Interest was really growing and trust was building at that point in the 2013 to 2014 range. Since then, we really had some pretty wild organic growth all the way up to around 2019, and that was really driven by incremental application migrations, your typical lift and shift of systems from on-prem into the cloud hosting. But also a significant amount of cloud-native development. Our entire reservations ecosystem is now being transitioned from legacy-based back-end mainframe-hosted applications and distributed applications into cloud-native services. So if you're interfacing with the Amtrak mobile application or Amtrak.com, 100% of that is hosted in AWS, and significant portions of the back-end application logic is built cloud-native, running on AWS services like Lambda, DynamoDB, and a significant MuleSoft-hosted microservices layer that is also an Amazon-hosted product as well. So that organic growth happened over the course of about the next 3 or 4 years, and we started experimenting and deploying platform as a service capabilities. That really got us to 2019. I joined the company in 2018, and one of my first jobs was to look at our infrastructure services cost and how to accelerate even more of our cloud adoption. We made the decision to sunset one of our 2 legacy data centers. Migrated a tremendous number of applications straight to AWS, focused on cloud-first application adoption, and that was really the first time that we started deploying mission-critical applications into the cloud. And then the other thing, the benefit of all of that adoption was we were really ready to transition to 100% remote work capabilities, because so many of our mission-critical business services as well as employee-facing services were already hosted in the cloud. So it was really almost an overnight switch for us that ended up working out quite well. Cloud 2.0, we're really at the next level of our cloud journey, where we're going to share many of the use cases of taking those basic building, lifting, shift capabilities into Cloud 2.0. But a few statistics really overall. Right now, we are running probably greater than 70% of our workloads are hosted in the cloud. And that includes, and I'm including our mainframe backend systems in that remaining 30%. So it's really been great adoption. And again, we are a cloud-first organization where a lot of our new custom development applications are developed and analytics using all the cloud-native tools. Finally, let me talk about sort of the enterprise environment. So it's not just enough to say that we're operating in the cloud and we're moving these systems to the cloud. We have to really think about the entire infrastructure environment to make that possible. So Amtrak serves, I also oversee all of our network engineering services. Amtrak has about 700, actually it's close to 900 individual physical locations where we have to provide IT and technology services. That means over 900 individual locations that have to plug into our network in some particular way. At the center of our particular network architecture, it is engineered for cloud adoption as quickly as we possibly can. We've got MPLS and SD-WAN based services that connect to Equinix-hosted routing centers and hubs. So we host our security devices, our edge protection in Equinix-based services, where we can leverage direct connect to the cloud cross-connect services. So essentially, it's as easy to connect to AWS's ecosystem as calling up my Equinix service guy and saying, plug in another cross-connect to this particular switch. We designed that on purpose, and our 2 on-ramps into AWS and cloud services are hosted here out of Ashburn in the DC area, as well as in Chicago, so we have primary and redundant. And we're also using those same network infrastructures to support our cloud resiliency and cloud disaster recovery capabilities, which Srikant will talk about more later. So I wanted to just talk about this because there is a lot of readiness and preparation and infrastructure capabilities around our networking design that has really helped us with cloud adoption for both end users as well as applications. So I'd like to have Srikant come up now, and he'll talk about some of the specific case studies for our examples.
Thank you. Thanks, David. Great introduction. And Bob, I always learn something new from you. I didn't know we had actually 900 locations, physical locations. So I'm going to take this story further, the business context that Bob gave, and some network overview. Let me take you into the details where they say devil is in the detail. But in our case, you will see lots of angels we also found in details. And the reason being, this team that we work are amazingly hands-on and very knowledgeable. So as we go down the lane with this onion and just peel them, you do see angels. And we'll just share what we call this and why I call this as a continuous maturity model. So as you see, our journey was typical lift and shift, where you start very safe, no refactoring, no re-architecture, lift and shift went fine. And then now we are at cloud native architectures. And this journey is not just adopting new technology services. The people, the governance, the process, collaboration has to be matured. So in my session, when I will take you to the details, I will also talk a lot about the interdepartmental governance. That makes sense. That's more critical. So as I said, we started with pure IIS model for lift and shift. So that's okay. I mean, it works fine. Pre-cloud days, it would take 3 days to get a server, sometimes 3 months, and now you get in one day, 1 minute, maybe half an hour. But we got greedy. That's not enough. What happens is the EC2 based architectures work fine, but there is a lot of workload, administrative workload that you would experience. Take an example. If I were to spin up one simple EC2, it has to be hardened. Hardening for us is about 100 to 200 points. And it doesn't end there. After hardening, you have to have a life cycle of patching, life cycle of agent installation. OS version will expire. Security patches will come on. So as you see, there are hidden costs to IIS-based architectures. And I understand there are workloads such as COTS product, SAP products, they work on IIS. So we do have significant portion of those applications who came from on-prem on IIS. But what happened, as Bob was mentioning, we started adopting cloud native, serverless carefully. Why do I say carefully? Because we need to make sure the ecosystem also develop. Our developers also know how those services. And today we have integration platform as a service on MuleSoft, which again is on AWS. And of course, then there are platform as a service, including RDS and Lambdas and Beanstalk, everything, including the containers. As we matured, we had to think beyond a region. So we also started cross-regional resiliency architectures. So what I'm going to do today is I will take you through very interesting real-life use cases of how actually it happened, how we partnered with AWS, how we internally partnered, what difficulties were there. Everything that we will show in the use cases are live in production. So with that, this is a view of last year's Cloud 2.0 initiative. Our year actually ends about what? Next 2 days.
Tomorrow.
Tomorrow.
As a matter of fact.
So this could be a journey of this year. This literally is exactly what happened. I call this as a transformational initiatives to make cloud ecosystem stronger, more resilient. So I tell my boss, that these are initiatives that won't make you handsome, it will make you healthy. I can't show you a cute application and say, wow, this is how I created this mobile. I will not show you that. But with this, there could be hundreds such mobile applications that can be quickly developed and reduce the time to market. So we started with our key objectives. What are key milestones? Then we had a lot of good reference calls, thanks to David, his team, and Amtrak's other AWS customers who have done similar things. And good thing about those calls is he's never on the call. His team is never on the call. So it is trusted, take-it conversation. After that, we talked to Gartner. We felt it whether people are doing successful. And then we started what I call as a blueprint phase. Very important phase. We are changing the whole foundation from single account to multi-account. The time it takes to do the blueprint is actually more than the time to implement it. And you will see why when we go to that slide. After blueprint phase, we realized that without automation or infrastructure as a code, it's not going to accelerate. So we spend significant amount of time in automation, adopting infrastructure as a code, do it wherever possible. It also gave us service catalogs. Service catalogs are to enable our internal customers and give them self-sufficiency. They should be able to, within a confined guardrail, create their asset and not come to us for small things. So that is AWS Service Catalog, end-user self-sufficiency, and there was an implementation phase of multi-account control tower, and we expanded to very complicated use cases of disaster recovery and cross-region resiliency. And this actually happened in this year. We are already live with many of them, and this disaster recovery will continue into FY22 for very complex applications. So I would say this is the initiative, this is the pattern. Start with references, do blueprint, scorecarding, and then go live. So I will walk you through some use cases of each category, and we will go into detail as the time permits. I'm going to leave aside maybe 5 minutes for Q&A, and then we can also have Q&A on the side. So before I take you into the use cases, very quick view on what is our cloud ecosystem. What Bob walked you through was enterprise networking ecosystem. Now I am drilling down into AWS specific ecosystem. As you see, this is a very typical AWS implementation. You start with the left, 3 regions, Ashburn, Ohio, West Coast, and on the far right, we have our corporate assets, the mainframes, and somewhere here, those 700 locations that Bob was talking about are connected. Outside this, the communication between AWS and backend is through transit gateways and Equinix. Here you will see there is a lot of redundancy in network traffic. Cloud Exchange is not one, the cloud exchanges are 2. One is in Ashburn and one is in Chicago, so 2 Equinixes. Both of them talk to our backend system. Firewalls there. Our integration platform as a service provider, Mule, also talk through Equinix and also connected to us. So if you see from the IP, for those of you who are network centric, there is a lot of work done here for mapping the IPs, deciding there is no IP clash, making sure that this whole thing functions as a unified corporate ecosystem. At the same time, it has adequate level of isolation. So just keep this picture in mind. Again, multi-region, left to right, through cloud exchanges, transit gateways, integration as a service, talking to backend systems. So this is a use case of disaster recovery and what I call as a cross-region resiliency. So I'll use a quote which all of you should know. Everything fails all the time. And most of you know that this is from CTO of AWS. It does fail all the time. So what do you do? So this is a case, is try to answer to some extent what can we do. It's about the positive train control. It is for accident prevention. It has to be up 24/7. It covers 19,000 track miles. So before I take you deep into that architecture, Bob, can you give them some business context in a minute or so about PTC?
Sure, I'll talk about PTC. So within the context of our AWS and cloud native services, we have built out a fairly critical component of the end-to-end positive train control system that covers all of the territory outside of the Northeast Corridor. So there should be a business scenario where Amtrak trains are running on another host railroad's environment, and there's a fairly complicated interoperability system that's set up to communicate, so that allows a tenant train, in this case, an Amtrak locomotive, to operate safely on a host railroad's network. One of those key things is the locomotive has to initialize with their route. They have to communicate with the host railroad's back-end system. We do that with a set of highly resilient multi-region PTC initialization-based services that are hosted in Amazon. And that provides us in-region, always-on, 24/7 failover capabilities for those very mission-critical safety systems. And Amtrak was successful in meeting the federally mandated PTC rollout deadline of the end of 2020. And this particular service was a key part of making that work outside of our own territory.
Thanks. Thank you, Bob. So let's get into the technical aspects of this. So why go cross-region? As you already know, a single region itself offers intra-regional resiliency with AZs, 3 AZs to 5 AZs. So we already adopt that. We already have multi-AZ architecture. That's not enough, because even if AWS is stable, what if there is telecom outage, which actually was there about a couple of years ago. That led to this. So therefore, we created one more identical mirror site in US West. And every layer, as you can see in the details, is fault tolerant. So let's take a deeper dive into a business architecture and a technical architecture. Again, we go left to right. Train, cellular towers, initializes, goes through the Rockwell Collins, communicates with AWS, gets the response back. AWS talks to backend if necessary. A lot of data is cached, so it is not always necessary. This is a high-level architecture, a business architecture of how this thing works. Now, if I take you further detail, what I call under the hood, maybe I can go here first and come back. No, let me stay here. So it is active load balance DR. It is not a passive. It is not standby. It is active. What I means is both AWS West and AWS East are operational and taking the load. The signal goes to Route 53. It is a 50% weighted average, and it goes to a region. Within each region, you are going to see an platform as a service implementation using Elastic Beanstalk, DynamoDB for the cross-regional persistence layer, and everything built with AWS services in this life cycle. So it is not DR alone, it is active-active load balance. So how will it look like? It's like this. I'll spend maybe 5 minutes on this slide. At the top, there's a Route 53, which decides, depending on the 50% route, which a request goes. It can go to the US East or US West. Both East and West are identical in terms of code footprint, in terms of architectures. If you see, if I look at just one region here, the US East, you will see we are using intra-region resiliency already, because the elastic bean stack that you see is on 2 AZs. An elastic bean stack takes care of load balancing, fault tolerance, auto scaling. All developers have to do is to deploy their code, deploy their zip file. In our case, it will be a WAR file because it's a Java-based application. Beanstalk takes care of itself. It gives you fault tolerance. Load balancer, we are very familiar with those. What about the persistence layer? So persistence layer in this case is multi-master replication. It's a DynamoDB, NoSQL with eventual consistency. And therefore, this is the beauty of this solution, that my data is actually not lost, because DynamoDB internally also gives you highest level of durability because it uses multi-AZ. In addition to that, now this DynamoDB is copying across the region close to real time. This is just one region. Now exact same region exists, exact same architecture is on the other region. And the DevOps or DevSecOps is designed in such a way that the code is identical on both the sides. So as you see, very little of manual work happened here. The traffic routing, DNS, AWS, load balancing, AWS services, replications, AWS services, and we will also see something else, which is monitoring. This is a C1 class mission critical system where if anything goes wrong, there are 40 people on our incident response call, which he owns, which we call that severity 1 or 2. So there is a lot of monitoring, alerting, and again, it is natively integrated with CloudWatch, all these systems. So we get health checks, we get notification. Of course, you can log into the console and check it yourself. So not to jinx this thing works fine. It is live for a while now.
And I'll just add that this is the perfect example of our highest level of application resiliency standards, where we are deploying an active architecture, and either one of those can work at any time. And so we'll, based on the criticality of the service and the IT service, we'll kind of scale back the complexity of those types of solutions. And I think you're next going to talk about a lower level, maybe something that is more of an active-passive type structure and model that we've also are deploying out in AWS.
So now let's, I want to go to a pace that is not very fast, not very slow, and still give you some information about what happened. So I mentioned you that governance is as important as technology. All this solution that I was talking about, the governance was a key factor. Security, the architects, the implementation team, incident response team, monitoring teams. So they were involved all the time. It is not just technology, we have very strong internal governance. Now let's take a case of advanced use cases. These are some very advanced use cases. So if you have a straightforward 3-tier application that has 3 servers, you can easily replicate across. AWS gives you very simple backup services and replication, and you're done. But not all applications are like that. In this world of microservices-based architectures, what happened is our reservation system, for example, it will go across platform. It will go with Akamai as a content delivery network. It will go to MuleSoft for integration as a service. It will come to AWS. It will come to payments gateway. It will go to backend system. 5 or 6 layers, microservices. That's not easy to DR enable. And therefore, we have a classification, C1, C2, C3, C4. These are very similar to what you guys call as a platinum, gold, bronze. Based on that classification, we use how much do you want to automate? How much of attention should be given? Should it be active-active, like you were saying, or active-passive for saving the licenses? Should it be hot standby? And there should be DevSecOps practices so that it can be built fast and the code deployment is region agnostic. So let us take a scorecard. There are, when we take a system for DR evaluation, there are about 25 lenses, or what I call as scorecarding. I am going to, for the sake of the time, I will only take 3 lenses, critical lenses. One lens is the platform scope. What do I mean by the platform scope is we need to clearly understand what is this application, how many layers it goes through, how many platforms it goes through. Does that platform itself has a capability to provide you DR? Because AWS can, but what if your partner cannot? Once you do that, you have to track every single API, every single microservices and check what happens there. Lot of work. Blueprint phase. This is where we need to work very closely with development because they knows this, how the API calls are. Once you have an inventory of a very complicated list of API calls, then you go to, okay, fine, what is my persistence layer? In some cases, it is a NoSQL, and you are very lucky. NoSQL give you eventual consistency, real-time replication. We just saw the use cases. Some cases it is easy because you can use the backup services. AWS backup services works fine. How do we do that? Let's say we have, I'm just giving an example, 50 assets. And of that 50 assets, 5 are C1 class assets, where my SLAs will require me to copy every 1 hour. So backup service is intelligent enough to know the class of your application based on your tagging. It is intelligent enough to only take that data to the cross region, cost effective. Then it's a logical combination. When you say EC2 with 7 attached volume, it is going to consider it as a 1 unit, take it there. At the frequency you define. On the other side, we have our DevSecOps team who have automated this so that you know which is the latest one and how to bring it up on the other side. Lot of good work, lot of complicated, and this is where sometimes we partner with AWS professional services and we say this is what we want to do. Tell me now that are you not building something product next month? And I would have created one more product here. And they say, no, this is okay. So we have worked with professional services guy for such very complicated stuff. My team is very, very hands-on, and they do more than 90% of this work themselves. On this persistence layer, if you have a relational things, then most of these relational things for Aurora, I am okay with red replicas cross regions, and recently, I think yesterday, Bob, we went live with Microsoft Always On for in the police department C1 class application. So this relational database replication works. It is not as real time as NoSQL, but it is perfect. It is okay. It's good. So that was the persistent storage layer. The third one is again very important. What about networking? You have one exchange. What if it goes down? So we have 2 exchanges. We have 1 DNS service. So we have 1 more DNS service. This transit gateways and direct connects, they are not appliances, they are configurations at AWS. So there is no single point of failure, because you will ask me what about them. So they are services and they are configurations. So this is very involved, interesting, and extremely satisfying work to take an application and DR enable it. Now I am going to switch, and I have 10 minutes. I have 2 use cases. I will move it fast so that gives some time for a Q&A. This is a multi-account structure. Anybody here has implemented multi-account structure, is considering? Okay. So before multi-account, like many of AWS customer, we had a single monolithic account, and like any other customer, our landscapes isolation was based on what? VPCs, 7 VPCs. What does it mean? 7 internet gateways, 7 network connectivity, everything in one. That is huge blast radius for security. And then came AWS Multi-Account Service. We are live with Multi-Account Service. Time spent in figuring out what should be the multi-account is going to be more than time to actually create it, because there are different models of here. Do you want to have multi-account based on landscape? Do you want to have multi-account based on business units? Very good conversation. How long this conversation went on? More than a month. And me and Bob used to say, Bob, how do you want it? You want to chime in about those conversations?
Sure. So yeah, that's really a business-based decision and has a lot to do with how your company is organized and how you're structured. And Shrikant was very patient in letting the technical teams partner with AWS and our solution architects to come up with various pros and cons on how we could set this up. And structure this. You know, I had an idea in my head, but it was really important that the time was spent looking at options and coming back with recommendations. In the end of the day, Amtrak really operates as one operating unit. We have one operating entity, and we have a single enterprise technologies organization. So we felt at the end, you know, trading off sort of management complexity and structure design to meet our needs, that a landscape-based approach made sense. So we have accounts for legacy systems that were stood up and that will be migrated into a new structure over time, and then dev OUs, development, test OUs, stage, and production OUs. So we're really focusing on a landscape-based environment that really our ITsec organization is very satisfied with that, because we're now separating from that security blast radius the production assets from our non-production assets by organization. And so that was the right structure for Amtrak.
Thank you. A lot can be said here. I'll just say one quick point and then we'll move on. The predefined guardrails. I can have elective guardrails, I can have mandatory guardrails, detective guardrails, preventive guardrails in each category. RDS category, S3 category, network connecting category, encryption category. I can define those rules and tighten it as I want, depending on the nature of account. And another most important thing is there are horizontal common accounts such as network services and shared services. What is the beauty of that? Here it is. Before multi-account, what we had? NAT gateways for each VPC, internet gateways for each VPC. Networking was very complicated. Which 3 types of traffic come to us? Inbound from internet, outbound to internet, and intra VPCs or within Amtrak. The beauty of this design is this whole thing is in only one account now, which is network services account. I have an ability to have an inspection VPC with a firewall there for all inbound and outbound traffic inspection, and my implementation of internet gateways and NAT gateways becomes very simple at one place. This is a logical diagram. I cannot show you the physical diagram because which has a lot of IP ranges and it's a proprietary information, but in short, this is a very advanced networking that our security likes. We are considering using additional firewalls in addition to whatever we have at central place. This is a networks multi-account that is common for all the accounts. Now, this is my last section, DevSecOps. So far what we talked about was infrastructure, the continuous adoption of new infrastructure services. We talked about isolation, networking, multi-account, DR. There's one more very critical aspect, which is the development lifecycle itself, the SDLC. And this is where we have done tremendous work. And we have hired some great people from outside. And basically, a lot of emphasis was on infrastructure as a code. Infrastructure as a code would include automation, it would include code scanning, creating a Jenkins pipeline as a code, and it is everywhere. It is used in multi-account creation, it is creating in account creation, it is used in service catalog provisioning, it is used everywhere. So I can't emphasize how critical is DevSecOps, even if you have a very strong infrastructure team, because that's only one layer. So a good example of DevSecOps is this. It's a conceptual diagram for pipeline as a code. As you can see, we have built pipeline as a code concept using Jenkins. So from Bitbucket to the deployment, you have a code. It is a continuous integration and selective CI/CD. It will take the code, do a status check analysis, dynamic check of vulnerability, SQL injection scans, cross-site scripting, and several other things that are defined as red flags. That's a code quality check, and then it is implementation. This is an example, and this is my last slide, last topic. We also adopted containers. As we started, we were with EC2, then we went with the Beanstalk, we went with the Lambdas. So in our tools, we had these three things, but we started with containers this year. So we had two options to decide, should we want a EKS, which is Kubernetes AWS managed, or you want ECS, which is AWS native, with of course Fargate. We evaluated, the scorecard was again 40 points, and we decided that we'll start with ECS, natively integrated with every AWS service, including IAM, role, Fargates. And we went live with the Jenkins, and I will show you how. Key point of this slide is when we have an option to implement ECS, it could give you EC2 based deployment or Fargate. Fargate is EC2's 100% managed autoscale by AWS. So this container went live, and we went live with a very challenging concept, which is containerizing Jenkins itself. It's like a chicken and egg situation. So Jenkins is a deployment platform. Now we want to containerize Jenkins, so I can't use Jenkins. So we used AWS code build. So essentially, this whole thing is infrastructure as a code. Starting with the Docker file on the bottom, it pulls, it will create a Docker image, moves into the container registry, ECR, and then ECS, of course the code build does that. ECS does a Docker pull, and it will create the Jenkins master node, Jenkins server node, code scanner tools. So this whole thing is actually zero manual effort, infrastructure as a code for the containers. This is going to be the reference architecture for my development team. Now I am going to skip this slide, which is secrets manager, but I am going to say very quickly. Now there is no fear in password rotation because we use secrets manager. There is no passwords in an email because it is stored in secrets manager. There are API calls, and this thing is our InfoSec's favorite thing. This is a pseudocode. Now this is a very critical slide. We should talk about it maybe for 2 more hours. This is the governance that we are talking about. So we start with executive support right here. With the executive support, we have vertical customers, just like AWS has, like SLR, marketing, omni-channel. Then the horizontal layer of departments or partners, very critical. Solution architects, network architects, development teams. Even AWS plays a role here. And then all last 2 layers, managing the PaaS layer, platform as a service, deep knowledge into each area is our group. And this whole thing is of no use if you don't pay attention to the cost control. We have to do a cost control, the chargeback model, the showback model, and keep on right sizing. We cannot have somebody spin up 16 OCPU, vCPU machine and just forget to turn it off. It was for a test. Cost matters. So this is the governance structure that plays role every single time. And with this, our story stops. And thank you for your time.
So we will hang around. We're out of town now. We will hang around outside the entrance to the room here and are open for any and all questions. So please, if you have anything you'd like to speak with about, please come right up. Thank you.